Thank you, everyone. It's great to be here. We're going to be talking about Pluto today. We're less than 3 months away from really finding out what it's going to be like. And before I jump into that, Vinny mentioned that I'm on the board of directors of the International Dark Sky Association, which for the past few years has had a booth here. They're not here this year. Budgets are tight. And I'm here to quickly deliver 2 quasi-political messages. First is, my sense is that very few amateur astronomers, the people who have the very most to gain from the International Dark Sky Association's success, are actually members. May I see a show of hands of those of you who are members of the IDA? Thank you very much, and that's not very many of you. Second thing I want to mention is that right now, all across the country, thousands of communities are determining or are planning to switch their streetlights to LEDs. Now, LEDs can be very, very good, and they can be very, very bad. Davis, California had a situation where the town installed LED streetlights that were so bad, they actually had a recall, if you will, and the town is having to redo them. I ask you, on behalf of the IDA, to find out what's happening in your towns. Be proactive. If you don't want to stand in front of the city council to fight for high quality lighting, that's fine. Let me know. I'll be happy to do it for you. Okay, on to Pluto. First, a little background. Yeah, you know, this is going to be old news for some of you, but we live in a remarkable solar system with an incredible diversity of worlds. These planets all form together, and yet they ended up so very different. We've got little rocky ones near the sun. We've got big gassy ones in the middle. We've got ice giants out beyond that. We're not really sure how they formed, if they even formed where they are now. Probably not. But what we do know is that there is this great diversity. Here are the gas giant planets, the biggies. Here's a kind of a cartoon that shows, in crude terms, rock in this diagram is like rock and metal, things that are solid at most temperatures. Ice is all of the things that are what you would call volatiles, not just water ice, but carbon dioxide, ammonia, things like that. And then gas is almost, in this case, hydrogen and helium. I teach astronomy in high school, and I tell my students, if you don't know the answer to their question, just answer hydrogen. More often than not, it'll be correct. So you can see there's this variety of compositions, but even among the major planets, though they have their style, they're this host, this zoo of these smaller worlds of different sizes and shapes. And I put in this list a couple of, you see the moon down here. It's not nearly the largest of the satellites. Titan and Ganymede are satellites that are bigger than the planet Mercury. Just remember that thought. And then down here is Pluto, out at the edge of the planetary system. So this set of worlds that we have, you know, the ancients knew about 6 of them, if you count the moon as one of those. And then we realized that there was kind of a hole here. Some of you know about the Titius-Bode law. What you might not know is that in the late 1700s, European astronomers were so convinced by the Titius-Bode law that there was a missing planet that they set about to find it. They called themselves the Celestial Police. And that's a whole story for a different time. But on January 1st of 1801, an object was found in here that we now know as Ceres, and we're getting our very first good looks at Ceres thanks to the Dawn spacecraft, and I know Mark Raymond will have a lot more to talk about that later this weekend. But Ceres in very quick succession, Ceres, Vesta, Pallas, and Juno were discovered. And they turned out to be some of the four of the very biggest objects in the asteroid belt. And so astronomers thought, oh, look, we've discovered 4 new planets. And so they got their own symbols, they got included in tables. No more were discovered for a while, and then they started being discovered by the dozens and hundreds, and we came to realize that these are not planets, that they are objects in that belt that we've come to know pretty well. Here, you'll see more of this later, but this is what Ceres looks like close up. Ask Mark Raymond about this little white spot here. We think Ceres has a lot of ice in it, and that might be an exposure. Vesta we know to be a planet with a sort of volcanic igneous surface. And I show you this, here's a whole bunch of other asteroids that we have actually visited. So we have a pretty good idea of what the asteroid belt is all about. And we're completing the inventory of the solar system. And one of those objects that has just been too far away to get to until now was the planet Pluto. So let's talk about Pluto. Pluto's a very interesting, has been an interesting object from the get-go. It was, as was Neptune, Pluto was predicted to exist before it was actually found. John Herschel thought that there was a planet out beyond Neptune after he discovered Neptune. And then things got really heated up about a century ago when William Pickering, who was an excellent planetary observer, and Percival Lowell, who had a lot of money to become a planetary observer, were duking it out in terms of their predictions for planet X. And they did the mathematical calculations. I think you know the story. Neptune was predicted to exist because of the perturbations it had on Uranus's orbit. Uranus was not going around the sun in the smooth way that it should, so mathematicians, 2 different ones, predicted that there must be another planet out beyond Uranus. Lo and behold, there was. It's Neptune, it's big, it's massive, it did exactly what it was supposed to do, but the calculations suggested that it wasn't quite taking care of all the motion in Uranus's orbit. There must be another planet out beyond Neptune, and that's what these predictions centered on. Well, Pluto was discovered in 1930 as the result of an intentional search by Clyde Tombaugh, very young Clyde Tombaugh, who had come to aid this planet search at Lowell Observatory. And Tombaugh, turns out, got really lucky fairly early in the process. Here he is as a young man. He had impressed the Lowell Observatory astronomers for his ability to create careful, meticulous notes of his observations, something that is still valued today. This is the telescope that he used to discover Pluto with. His was a really exciting and yet miserable life. By night at Lowell Observatory in Flagstaff, which can be a very cold place in the winter, he exposed big plates with this telescope, and a couple of days later he would go back to the exact same area of the sky and expose more plates at that same area. The thought was that if there was a planet out there, that the planet would shift. A special contraption called a blink comparator was made. So by night he was taking these plates, and by day he was blinking back and forth incessantly, these giant plates full of thousands of stars, carefully looking at each section until he found something that moved. Here's the discovery plate for Pluto. It's not this. It's this. Very, very tiny. Those of you who have tried know that Pluto is a very challenging object to find in a telescope visually. It hangs around 14th magnitude. And in this case, it turns out that Pluto was fairly close to where Lowell had predicted it would be, because that's where Tombaugh started his search. As it turns out, as you'll see, Pluto is not nearly massive enough to have affected the orbits of Uranus and Neptune. It was just down in the mathematical noise. By sheer luck, Percival Lowell had predicted in the right area of the sky, and by sheer luck, Clyde Tombaugh swept up Pluto early in the search. This is what he looked like at his home in Las Cruces a few years before his death. His trusty old telescope is with him. I was really happy to and honored to get to know him a little bit before he died. In fact, he made one trip out east to Boston, and he stayed overnight at my house, he and his wife Patsy. And so we've sold that house since, but the last thing we did before we closed the door and turned over the keys is put up this plaque. Notice it doesn't say whether Pluto is a planet or not. Okay, so Pluto was discovered, and it was the first planet discovered by an American. Lowell Observatory made a big deal about this. They were great at the PR, and eventually settled on the name Pluto, which had been suggested by a young schoolgirl in England, as it turns out. And yet, almost immediately, it became clear that Pluto was not the Earth mass object that they had thought it would be. So it became clear pretty soon, in the years after its discovery, that by following how bright and dim it gets over time, that it has a light curve, which means that we can determine how fast it rotates. And the rotation period turns out to be about 6 days. But that rotation period changes over time. The peaks and valleys get brighter and deeper, which means that either the surface is changing, or maybe the aspect that we're looking at Pluto is changing. It was all very strange and mysterious. Not long after that, it was realized by dynamicists that Pluto's orbit crosses the orbit of Neptune, and yet they can never collide. They're in what's called a resonance. Pluto goes around the sun in about 248 years. In 2 trips around the sun, Neptune goes around the sun exactly 3 times. They're locked in that relationship. And that relationship keeps Pluto from ever running into Neptune, even though, you can see up here, their orbits do cross. From 1979 to 1999, Neptune was the farthest planet in the solar system because Pluto was actually closer to the sun than Neptune was. And here's where it starts to get interesting. In 1976, Dale Cruikshank discovered a very strong absorption from methane ice, on the surface of Pluto. That's what these CH4s are. And this is a near-infrared spectrum. This is right at the beginning of near-infrared astronomy for professional astronomers. And they discovered that, yes, there's water ice, but there's also methane ice. Now, here's why that's important. Pluto is only so bright. It's 14th magnitude. It's a lot dimmer than it should have been. So either Pluto is really a big planet that's black, or it's a very small planet that's white. They would reflect the same amount of ice, same amount of sunlight. And this discovery meant that it had to be a very small object that was fairly bright and reflective. Okay, so that tells us a little bit about its size, but not exactly. The kicker came in 1978 when James Christie, using images taken at the Naval Observatory, took an image of Pluto. This is enormously enlarged, and he saw a bump on the side. And the bump moved over time. One side, then the other, then one side, then the other, every 6 days to match the orbital period that we knew Pluto had. And Christie concluded, that Pluto must have a satellite. Now, you know, Pluto is named for a god of the underworld. And so this whole naming thing is very important to astronomers, as we'll see. And so Christie was trying to come up with a name that was consistent with that. And he came up with the name Charon, which is another god of the underworld. Except that. So if you ask somebody how to spell that name, C-H-A-R-O-N, right? Those who don't know the story will say, well, it's Charon. That's how they pronounce it in Greek. But those who know the story will say, no, it's Charon, because Christie's wife was named Charlene. Okay, so fast forward to 1985, it turns out that Pluto and Charon are orbiting not kind of like this, like the rest of the planets are around each other, but like this. And it turned out that in 1985, the orientation of Charon's orbit, was going to line up directly with Earth such that it passed in front of and behind Pluto repeatedly every 6 days. This is good news because for those of you who have visited the IOTA, the Occultation Timing Association booth, you can learn a lot about an object from occultations. And so astronomers measured the dips, the little dip when Charon passed in front of Pluto and the bigger dip when it passed behind Pluto over and over again, and came up with new estimates, even smaller estimates for the size of Pluto and Charon. And so here's the tale of the tape. When it was first hypothesized, astronomers thought that Pluto's mass might be as much as 10 times that of Earth. When it was discovered, even by then, their expectations had lowered. And by the time methane, ice, and Charon were discovered, now we're talking about an object that is only a few thousandths at most the mass of the Earth. In fact, these are very small objects. This is an older graphic from Sky and Telescope showing their comparison with the United States. They're not big at all. All right, so Pluto's small, but it's got seasons. Turns out it's got an atmosphere. Turns out it's got surface markings as seen through the Hubble Space Telescope. Now, these are not Hubble images, just to be clear. These are maps made from Hubble images. Now, I'll show you a Hubble image in a bit. But Pluto has, this is what's causing the light variations as it spins. It gets brighter and darker, and the spots are moving around. There's seasonal motion caused by things, frost evaporating one place and ending up another. Or maybe there's clouds. We don't know yet. We're about to find out. All right, so Pluto was kind of going along, being this interesting place. It's got a moon, it's got an atmosphere. Yeah, it's small, but and we don't really know how it got there. It's in this resonance with Neptune. Then things started getting messy with the discovery in 1992 of another object out beyond Neptune that came to be called QB1. That's a shorthand. Eventually, these things get named, but Dave Jewett and Jane Liu, who discovered it, here we are more than 20 years since, they have yet to actually offer a name for it. The point is that QB1 was just the tip of the iceberg of literally thousands of objects that we now know exist out beyond Neptune in what is called the Kuiper Belt. By the way, I know many of you give talks. Some of you might know the name Govert Schilling, who's a very good science writer. I just visited Govert in the Netherlands. And Gerard Kuiper was also from the Netherlands. I said, Govert, how do you really pronounce it? He says it's Kuiper. Kuiper. So there you go. Paradigm change is underway right now. Anyway, the Kuiper Belt is part of a large trillions of objects out beyond Neptune that are leftovers from the beginning of our solar system. And it seems then that Pluto is just the largest of these, at least the largest one that we've found. There's still some thought that there could be objects out there lurking in the Kuiper Belt that are even larger than Pluto, and we just haven't found them yet. So the discovery of all of this started astronomers thinking, well, you know, maybe Pluto should be considered a minor planet, an asteroid, and that's where the talk started in 1992. And it got so bad that eventually the IAU actually had to step in and say, look, enough of this talk, Pluto's a planet, that's it. We're going to call Pluto a planet. History is telling us that Pluto should be a planet, so we're going to keep that way. Okay, so the main protagonist for this was a guy named Brian Marsden. You're seeing, here he is, he's shaking the hand of, Brian's on the right, Clyde Tombaugh's on the left. They met at Harvard. I happened to be there with a camera. They are both smiling, at least for the moment. But Brian was the one who really started pushing this notion of Pluto may not be a real planet. And the IAU stepped in and said, no, Brian, we're going to call it a planet. But then in 2005, the game changed again. Michael Brown and some others discovered an object out in the Kuiper Belt that is very large as Pluto or bigger. And they had all kinds of nicknames for it, Smiley and, not Smiley, Xena, right? Warrior Princess. That was the nickname. But it really did need a formal name, and therein lies the problem. Within the International Astronomical Union, there is a committee that names asteroids, and there's a committee that names planets. So before they could turn it over to the correct committee, they had to decide what it really was. And many of you know the story. Here's a sort of comparison of Eris and Pluto with some other objects that have since been found in the asteroid belt, in the Kuiper Belt. And there's a lot of big objects out there, but only Eris rivals Pluto in size. So we needed to know which committee to send ERAS to for approval. And so in 2006, it all came to a head. Some of you know this story. This happened to be a meeting that was held in Europe, and European astronomers have, word on the street is that the Europeans are still a little upset that the Americans made such a big deal about Pluto. And so they debated long and hard whether Pluto should be considered a new class of planet, this dwarf planet. And they've used props. Is it a big tent that everyone's a planet, or is Pluto on the outside looking in? Interesting thing about the IAU, many thousands of astronomers are members, but only one can represent each country, and they get a yellow card. And so this is the vote. This is the vote to accept Pluto's demotion to dwarf planet status. Now, what does dwarf planet mean? The IAU in this resolution actually defined what a planet would be. It's an object that is in orbit around the sun, so I guess that means that all the thousands of planets that we have found now orbiting other stars don't count. And interestingly, they didn't define what the top size end of a planet must be, which is actually fairly well defined. No, they were fixated on the small end. So it has to have enough mass to be round. And this is a pretty simple concept. You've seen lots of pictures of craggy little asteroids and such. That's because the mechanical strength of their rock is stronger than the pull of gravity to try to pull it into a spherical shape. But if you get big enough, eventually gravity wins that argument, that fight, and gravity pulls all the mass into a sphere, more or less. And so it has to have enough mass to be round. Turns out that's about 600 or 700 kilometers across, depending on the mass of the object. And here's the kicker. It has to have cleared the neighborhood around its orbit. It has to be mass. What they intended was there has to be enough mass so that if there's some other smaller object lingering around, that smaller object is going to get kicked out. The analogy I like to use is you all remember back to your school days, or if you're young enough, your current school days, and there's a big bully he and his posse are like gamboling across the school playground. Do you go right up to that bully and say hi? No, you stay as far away from that bully as you can. That's clearing the neighborhood. And that's what they meant by clearing the neighborhood around Pluto. Pluto did not meet that criterion. It's not massive enough to do that. One of these is considered massive enough. That's Ceres. Vesta is not. We've seen these now both up close and personal. Earth, is Earth a planet? Is Earth a planet? Well, yeah. Except that if we put Earth out where Pluto is, it wouldn't be massive enough to clear its orbit. So it wouldn't be considered a planet. Okay, that's the Pluto story. Now let's get on to the discovery story. And the discovery story is going to happen very soon, and we're going to know exactly what's going on with Pluto and exactly what it's all about. There's a spacecraft called New Horizons, which has been en route to Pluto since 2006, January of 2006. Here's its launch. It was launched from Cape Canaveral. It was the fastest object ever to leave the Earth. It crossed the moon's orbit in only 9 hours after launch. It was really heading out of town. As a little aside, unfortunately, it was launched before Clyde Tombaugh. It launched after Clyde Tombaugh died, but his widow, Patsy, was still alive. The New Horizons spacecraft carries a small vial of cremains of Clyde Tombaugh, so he's going to get to see his planet. It made a pit stop flying by Jupiter, really just a year later, and used that to pick up speed to get out to Pluto. It did a lot of great science at Jupiter. Nobody remembers really. New Horizons did fabulous science. We hadn't been to Jupiter with a spacecraft since Galileo in the mid-1990s. So we saw a lot of things new, or again, this is a little GIF animation of a volcano erupting at the top of Io. Credit to New Horizons. Well, we're getting near its actual objective, which is to fly past Pluto and Pluto's family. This has a really great long telephoto lens on board called LORRI, and LORRI has a focal length of about 2.6 meters. So it's a very powerful telephoto, and this is showing from last July Pluto and Charon going around each other. Here's a more recent one showing Pluto and Charon, and just from really a couple of weeks ago. And I want you to notice that Pluto is not staying still. They're actually both orbiting around their common center of gravity. So this is very interesting. We've never really encountered a situation where, you know, the two objects, the main two objects, are so close in size. Well, when New Horizons was being designed, Pluto had only one moon. Then, in the year before it was launched, we discovered two more moons, which came to be called Nix and Hydra, thanks to Hubble Space Telescope images. And we now know of two more moons, even smaller, called Styx and Kerberos. And why is this important? It's like a bonus time, right? Instead of just photographing Pluto and Charon, we get to do these other moons too. The problem is this. These moons are so small, probably just the smallest ones, just a couple of miles across, that if something hits them, a little impact, the dust that is raised, these objects don't have enough mass to bring the dust back. So the dust escapes. So that means that there could be dust particles all around this system. And flying through the system at 9 miles a second, a small particle of dust hitting the New Horizons spacecraft could be catastrophic. So it turns out that, astronomers got really worried in a hurry, and they concluded that the safest place to fly through this system would be near Charon's orbit, near the inside, because Charon would serve to kind of sweep up these particles, kind of do a clearing. And that's exactly where New Horizons is going to go. So it's going to go fairly close by. This is the timeline. It's going to be a very quick visit. And don't expect a steady stream of pictures coming back from the spacecraft. This is going to be on July 14th. If you can't remember that date, it's Bastille Day. And it's going to be a very quick visit. The times that you see along the yellow line are in universal time. It's being controlled by the control center, not at the Jet Propulsion Laboratory, but actually at the Johns Hopkins University's Applied Physics Lab down in Maryland. It's going to come within about 8,000 miles of the surface of Pluto, about 15,000 miles of the surface of Charon, and then two very interesting things are going to happen. Again, I mentioned these occultations before. After it's gone by, New Horizons is going to fly into the shadow both of the Earth and of the Sun. When it flies into the shadow of the Earth, a radio beacon from the Earth is going to be passed to the spacecraft, and just as Earth is about to set, that radio beacon will pass through the atmosphere of Pluto, which we know to exist, and Charon, which we're not sure. And that will tell us the extent and the density of any atmosphere around Charon and around Pluto. Then, meanwhile, it's also going to pass in the shadow as seen from the Sun, and as the sunlight passes through that atmosphere, we'll be able to tell something about the composition. It's a great, powerful technique. So here's our spacecraft. It's got 7 experiments. RTG up here stands for the radioisotope thermoelectric generators, the plutonium that it carries to create the electricity to run. There is an experiment called Ralph, and then an experiment called Alice. And yes, they are named for the honeymooners. But it's a very powerful instrument suite. We're going to have terrific images. We're going to have spectra. We're going to have magnetic fields, solar wind measurements. One of the things that astronomers think is happening is that Pluto is so low mass that a lot of its atmosphere is escaping, and we'll be able to measure that. So here are the players for this upcoming flyby, sort of scaled using the moons of Saturn. And I thank Emily Lakdawala from the Planetary Society who put this together. So using moons of Saturn as proxies, this would be Pluto, here's Charon, and the other 4 little satellites. And they might look something like that when we finally get to it. Now, Charon, we mentioned Pluto and Charon a couple of times. This is a simulation of how Charon might have formed by something big hitting Pluto long ago. And the color represents heat here. And the collision spits off a blob that stays in orbit. And that's probably how Charon came to be formed and why Pluto's entire system is tipped up crazy like it is. The problem is we've been studying this place for a very long time and we know so little about it, really. This is the very best Hubble Space Telescope image. It's about 8 pixels across. New Horizons will exceed this come about May. And we'll start getting pictures back that are better than Hubble pictures. Again, here's that map. We know that the surface of Pluto has very dark areas, which are probably like organic tarry goo. We know there is methane there. So when sunlight strikes methane, it's easy to break apart into the carbons and hydrogens, and they recombine to make goo. All right, that's official. And so we think that the surface really is tainted orange from some of these compounds, and there are bright ices. It's going to be a very interesting place. We have no real idea what it's going to look like. Some artists have taken a shot. Here's one portrayal, all right, down here. Pluto kind of orangish, Charon kind of whitish. Charon doesn't have any methane on it. It's just water ice. Here's another portrayal. This is by Casey Reed, who does a lot of the artwork for Sky and Telescope. We have a big article about this by Emily Lakdawalla in the July issue coming up. So you'll have your preview, your program. And very, very soon, this stamp will be obsolete. And I'm really looking forward to that. This has been 85 years in the making, this flight. It's been 25 years, 26 years since scientists first proposed a mission to Pluto, and it's taken this long to actually get it out there. Now, New Horizons mission won't be over by the time it goes past Pluto. It's supposed to be observing the Kuiper Belt too, and so after it goes past Pluto, it's going to home in on 1 or 2 Kuiper Belt objects that may have been discovered yet by the Hubble Space Telescope, and maybe not. But in any case, here we're going to be seeing at least 6 or 7 new worlds for the very first time of a very different sort. Getting back to those early slides, there's the inner planets, the inner rocky planets. That's the first zone of our solar system. There are the worlds that are giant, Jupiter, Saturn, Uranus, Neptune, the ice and gas giants. That's the second zone. We're now going to be exploring the third zone of our solar system for the very first time. It's going to be an incredibly exciting time, and I'm sure you're all going to be eager to see the results from that. So thank you very much for your time.
My first experience with astro imaging was in the 80s with a silver film, and it was quite painstaking. My parents, they bought the Celestron 8, and they let me doing my hobby. And I was the happiest teenager of the world. I was dreaming in front of the brochures with all the telescopes.
First major discovery was in 2006 on February 24 Universal Time, 25 local time. It is during that time when I took an image of Jupiter, and I discovered that its white spot oval BA has turned red. This spot is now known as a red spot junior. I had some people saying that, why the hell are you wasting your time in the middle of the night just imaging planets? And this is where amateurs fill the gap, and this is how we contribute basically to the development of the science of astronomy.
Celestron has always been about imaging. When I got that Celestron 8 back in 1975, one of the things that attracted me to it was it appeared to be built from the ground up to adapt directly to photography. The modern electronic imaging makes it so much easier for anybody to get into this and achieve good results quickly. People saying, oh, I just started imaging in 2008, and they're producing observatory quality work. Or I've only been in it for 10 years or whatever. And I'm thinking, my God, I'd already been doing it for almost 4 decades by the time they even started. So that's really been a joy to me, that the passion that I've been able to enjoy for 5 decades, now everybody can get in and do top-notch work right off the bat.
The rock case was one of the first cases I used a microscope in, and it became a huge case. And sometimes it's not the actual evidence that's there that leads you down a different road. Sometimes it's what's not there. So it's just things like that that may seem unimportant at the time, but become very important when you're testifying in trial. And I wouldn't be able to confidently testify to things like that without the use of the technology and use of the microscope.
They've been great for our curriculum because these students come in with very little knowledge of using microscopes, and trying to teach them on a standard microscope is very difficult because you can't see what they're seeing. I think with students today, they've grown up with technology, they expect technology, and then they get in the classroom and there's no technology. So having that technology there, I think, makes it feel more real to them. And I think everyone's fascinated by microscopic things anyways.
With these microscopes and the nice big large size of the panel, everybody can see what they're supposed to be looking at. I do love that everybody can be involved, and we have 6 of them, and so easily the entire class can be looking at different parts of the same insect or the same slide all at the same time. So sharing has just been really a plus, and they love it. They're so involved in what they're doing because the microscope is fun to use.
I think introducing birding and bird watching to other people is very important to the recreational activity of birding. The spotting scope is great. The Celestron Regal spotting scope it's really versatile, and one of my favorite things to do with that is digiscoping, and so that it's great. You don't have to carry your bulky camera around. You can just I carry my iPhone with me, and I do a lot of my photography with that, and with the Celestron scope it's just a clear picture.
Very competitive by nature, and when I got into imaging, I wanted to be good at it, obviously, and just like with golf and anything else really. But it's funny, just like with golf, there's all different types of people that do it, and trying to fit in my hobby with being a golfer and a dad and a husband, I mean, it's tough. So I've learned to process very, very quickly. I've become very efficient at it, and where some guys would spend, a week on one picture, sometimes I'm cranking one out and, over coffee in the morning.
Can one filter street light?
Yes, street lights have a few emission lines, primarily sodium and mercury, that can be selectively filtered.
What can you see on Mars?
On Mars, with this telescope, you'll be able to see the polar ice caps you will also see some dark Maria features on the surface of Mars.
Celestron has been instrumental in our support of teachers in their quest to birdwatch and identify birds and engage students in bird watching. They've donated many pairs of binoculars to the Cornell Lab of Ornithology's Bird Sleuth K-12 program, and we've been able to pass along these binoculars to teachers. Kids love tools that they can use to do science. If you put a pair of binoculars around their neck, they become scientists.